than bedtime videos for fun. This is just the checks for chapter 10, section 4, and of course the self check at the beginning. Hope you're well. Right. So let me get rid of this. I'm not sure if you can see this little drop down up here at the top. Anyway, doesn't want to go away, it'll stay. So we got good. Making videos is hard. There we go. Oh, good job. Okay. Skills check. First three, fairly straightforward two-step equations. Get rid of any addition or subtraction first. Typically, you don't have to. I chose just to do something different. Multiply by 8 first. Just multiply through everything by 8. Distribute and 8 is 104. And then 3. Here, guys, really, it's going to be helpful, especially when you are reusing a variable after you've solved for it, to leave it as a rational number. So 19 over 7. If you put 19 over 7, it's negative, but 19 over 7 in a calculator, you're going to get a repeating decimal. And if you try to use that repeating decimal, you're going to have to estimate it, and your answer is going to be less accurate. Please keep your solutions as rational numbers. All right, mixed numbers fine, but just rational in general. Okay, number 4, we're going to get back to factoring. We've got an expression, kind of showed my work over here. Figured it was going to be 2 times 14 is going to be 28, plus 1 more c is going to get me my 29. Ah, dang it, I forgot to write a c there, so I wrote it down correctly. Um, but this is that polynomial factored. Cool. Over here, 3p times p gives me my 3p squared. P times 10, 30p, 2p in the middle, 32p, 20. Awesome. Number 6, I should have recognized the 21 large number. Therefore, I should not have tried 2x as factors. My bad. Oh, dang it. Should have shot for the 4 right away. So come to find out, 4x times negative 6 gives me my negative 24x plus my 3x gives me my negative 21x. Positive 3 times negative 6 is negative 18. Awesome. Now we can go to quick check 1. Quick check 1 using the zero product property. Zero product property, remember, if you have a series of factors, if any one of them is 0, the entire product is 0. And since we are looking for when y equals 0 in a quadratic equation to find roots, finding when the factors of a quadratic equation equals 0 gives us that answer. Yeah, awesome. So pretty easy. You set each factor equal to 0, solve, you get negative 7 or positive 4. Same thing here. Set each factor equal to 0, add 5, divide by 3, leave it as a rational number. Awesome. Add 2 to both sides. Y is 2. It's very odd that they used y as a variable here. Not a fan. Okay, here we go. 6k plus 9. Leave it as a rational number. Same thing here. Add 11 to both sides. After you set 0, divide by 4, get 11 fourths. This gives you a nice, beautiful, actually both of these give you a nice, beautiful decimal. However, can I move this? Maybe I can. Oh, I can. Awesome. Still leave them as a rational number. All right. D, we have setting each of these factors equal to 0. Subtract 1 from both sides, divide by 5, negative 1/5, or h is negative 6. All right, just be mindful of your signs. So that's quick check 1. All right, quick check 2, they are going to give you the quadratic equation and expect you to factor it. If this presentation switches to the next slide. Here we go. So you factor it. So bam, you see my work over here. Since it's a difference, I needed a difference of factors where the difference between them was 8. Oh, seriously? Yeah, difference between the factors is 8. Goodness, second guessing myself. So the difference between 12 and 4 is 8. Largest of the two factors is going to be negative. So then here are my two factors. Set them both equal to 0. Solve for x. X is either negative 4 or positive 12. Pretty easy, straightforward on this one. All right. Quick check 3, solving by factoring. Now, you're still going to do the same thing you did in quick check 1, except for they're not going to give it to you with 0 isolated over here all by itself. Right away, you just have this one extra step. Add 36 to both sides, factor it. Now, what is unique about this one is that this is a perfect square trinomial. No, I think I'm saying that wrong. This factors into a perfect square binomial here, so x minus 6. So to prove that really you don't have to set x minus 6 equal to 0 twice, that just seems silly. It's going to be 6 both times. Whoops. So just set this whole thing equal to 0. Take the square root of both sides, add 6 to both sides. I wish I could make that go away all the time. And you get x equals 6. The only thing that's going to make that true is x equaling 6. So if you imagine the graph, that means that this quadratic equation, parabola comes down at x equals 6. The x-axis, and then up, right? Because the only time you only have a single root is when the vertex of the quadratic equation is touching the x-axis. All right, so now you know where your vertex is. It's at x equals 6. Something to keep in mind. All right, last quick check, real world problem solving. Where can I put me? Right there. So first, I drew the diagram on the left. This is the box with a length of x and a width or second dimension of x plus 1. They said we cut off 2 inches off of the side of the material. Therefore, the entire length is, the length is here, x plus 4. The entire second dimension is x plus 5. X plus 1 plus 2 plus 2, x plus 5, muy bien. And the area of the entire piece of material is 182 square inches. Therefore, if I multiply x times 5, the quantity times the quantity x plus 4, I should get 182. Go oil, 22 sides, I get this equation. I fit this quadratic equation. Pretty straightforward. To factor this with a difference because that's a negative of 9, and the larger of the factors being positive, pretty easy to figure out. It's 9 and 18. So that's my work over here. X minus 9 and times x plus 18. Set both of those equal to 0. Add to both sides. Here, set this equal to 0. Subtract 18 from both sides, and I find out x is either 9 or negative 18. Negative 18 inches makes 0 sense whatsoever, so we don't use it. So our answer must be 9 inches. However, our work is not done. That wasn't the question being asked. The question being asked was, what are the dimensions of the box? And I'm missing a dimension. I'm missing the height of the box. The height of the box is 2 because that represents the amount of material cut off here, which means that represents this distance. So when this flap folds up to make the box, the height is 2. My bad. However, the length is x plus 1. Sorry, I was flip-flopping on length and width. It doesn't matter, dimension 1, dimension 2. Technically, it does matter. Pay attention to how they refer to it in the problem. My bad. So the length is x plus 1. So since x is 9, the length is 10 inches. The width is just x. Therefore, the width is 9 inches. And the one missing piece here is height is 2 inches. So that's all the quick checks. If you did those right, you'll probably do the exercises right. Video will be coming out on those here in a sec. Yo.